for Kaylee's benefit. Yeah, so we're going to go today and touch on the whole setup that we're going to be running. So I created this in context of the system called Replit. This will allow us to really do things within within browser, so we don't have to mess around with kind of variants of the systems and setting stuff up locally. I'm obviously available to help you set that stuff up locally on your systems. There are going to be various discrepancies, whatever. So we'll just go and kind of run it in that environment, focus on Python, and then focus on setting it up at a later date. So today we're going to try to cover just the setup of the system, hello world, and kind of review of it. And we're just going to go through variables. That one is relatively quick, so we might start on collections, even though I kind of put it into upcoming sessions. And so I'll just keep updating it for the next dates, this page, as we go along. So let's take a look. So sign up on Twitch and all that stuff. So ideally you would do it on multi-screen for obvious reasons. So you would have this live video of coding along. And this system is set up so that you can actually code along and experiment with it. Let me know what's working for you, what's not, and where we are. And then we would experiment from there and kind of go forward. So the general, all right, you guys are good? All right, cool. So the lesson plan that we would go through. So we got our, let me just zoom in here just so that this is not complete madness. So this is kind of a mind map of the overall lesson of everything we're going to cover, not within this hour, but overall throughout. So we're going to start off today with variables, just kind of touch on our good old literals and various types, and mess with them and understand what's dynamic typing, what's strict typing within Python specifically, because there are certain discrepancies that you would see here, or there are various kind of ways in which types are handled in Python that are different than JavaScript, and so we'll talk about it there. And then if we get to collections today, hopefully there's a massive amount of collections within Python. They're all natively implemented. They're all exceptionally fast. And so we'll touch on them, and we'll go through a variety of capabilities those collections give to you. That is actually kind of a very strong point within the language, and that's one of the major strengths of it, and worth exploring and looking at. We're going to touch on strings because there's always all kinds of interesting things that are happening with strings with a variety of languages. Python is no exception. It has all kinds of interesting capabilities hidden there. The next one is datetime. I always keep saying that I'm kind of going off on a limb there, because there's a fair amount of I'm literally going to have various documentation pulled up in front of my face as I'm going to be doing this, just because there's a lot of quirkiness, but there's very nice date math that exists in Python that's very convenient, and that's relatively easy to work with. We're going to take a look at conditionals, because we have to, right? And kind of how they play out within Python. Look at how the ternary is structured, because that's kind of where you get your brevity from, right? Is writing a ternary expression for conditions. And then we're gonna go, I have filtering list comprehension. So one of the most powerful things within Python, and we're gonna look at it primarily once we hit loops, is comprehension. So it's ability to process and filter your collections at, in this very brief statements, and it's kind of the way to write Pythonic expressions in that sense. So we're going to hit that somewhere between conditionals and loops. Then we're going to touch on functions. That's our... Oh, Michael. That's you're off VPN? Sounds good. Okay. All right. So next one we're going to look at is going to be functions. So there we're going to, we're just going to go through how it's declared, how it's structured, and then the interesting structure behind the arguments, how are specific arguments passed into the functions, how are, you can have what you call it, you can have kind of flexible amounts of arguments. You can have default arguments and things like that. And then we're going to look at all the ecosystem around functions. Functions are first-class citizens within Python, so you can do a lot of very interesting stuff with that. Then we're going to look at modules. So the idea with how modules actually interact with each other, how they're declared, how they're formed, how the Python path works in relation to modules. So that's kind of very interesting and very important thing to understand, because there's a fair amount of libraries that leverage this order in which things get loaded in modules in order to initialize, in order to function, in order to attach themselves to the other systems and things like that. Then we're gonna have exposure to our good old friend object-oriented design, right? So we're gonna take a look at class, and we're gonna take a look at the structure of a class. We're gonna look at the interesting world of duck typing, which means that which is the reason why Python doesn't need either interfaces or dependency injection. So it's very interesting paradigm, and it allows you to do a lot of great things with mocking and things like that. There's a newer entity that is called data class that we will look at, and that is a development as of Python 3.6. By the way, they just announced Python 3.9 that came out. Then we're going to take a look at decorators and how do those work. Decorators are essentially what you know as annotations in Java. And another one that I have a fun exercise for you, is testing. So there is a TDD exercise that I have within that suite of in that suite of exercises that we will go through and look at how PyTest works and what's happening there. I don't necessarily have mocking and patching, but we'll be able to talk about that. So that's an overview of the entire thing that we're going to be doing over however many days it's going to take, and we might take a break for other things, but this is the overall goal here. So now let's go to I have this tiny button. I have never zoomed it in really, but it's called Run on Replit. So I want you to go and click on that and launch our project. All right. So what that's going to do, what that's supposed to do, yes, okay, good, it's working. So what it does, it's going to pull the actual repo for this project and going to give us the setup for what we're going to be working with here. So this is literally documentation that you just saw in front of you. So this is kind of entirety of the website that you see here. And so what we're going to do, kind of the key operation here. So first of all, the thing on your right is literally a Linux console, right? So I just typed in LSL and it lists all the files that are in this project for you. It's actually pretty cool. And that's just Replit is just an absolutely wonderful system. So when we spin it off from the Git repository, you have Linux console on you. So ultimately we could have just run entire course in here. So we could do, do something like this, and that means just showing that, and that we would be able to just run Python in console, right? Python is an interpreted language. We give it a line at a time, it interprets a line at a time and behaves on it. And within this REPL, so this is Python REPL. When you launch Python, it opens REPL, sort of like what Node does. Well, actually exactly what Node does if you just type in Node. And so you can run Python code in here. The deal is, however, I would like to explore it in the context of actual Python files out of the gate. So we're going to be working mostly in that environment. So to get out of this, you either hit Control-D, which is end of file, or you type in exit and open close parentheses. So you just run an exit command and it executes it and it exits. Okay, so I'm gonna type in, I'll just leave it so that you guys can see it. So we have this little world right here. So since we're leveraging Replit for everything, we are going to be using the run button to execute all our commands. And we are going to be, so the run button, as you can see right up over here. And then we are going to use Replit configuration to actually run a command. So it runs Python 3 and it's going to be running command Python, this one is hello world.py, right? So we're going to have that. And so what I'm going to try to do is, you see right now at the top of your current topic, it has if you have a question on how to get started, in Twitch chat, like if you were to open Twitch proper, you can go into Twitch chat and type in exclamation hello underscore help and hello world, as it is in green there, and it would literally give you a little help with link to this repo and with indication that you need to edit this file and add this line in there. So like it's going to be for all the sections, so in case you get disoriented a little bit, you can always look at that segment. I'll try to keep it up to date with what we're working on. All right, so enough of this excitement here. Let me know if you guys are okay and if the system is running okay for you. If you want to like drop it in the, you can drop it in the chat on Teams since you're running on my side here. Let me know. All right, and so we are going to go to do our basic first step. So we're going to just do the first command here. Without further ado, we're going to print okay, cool. So let's go. So we're going to type in print. So print is a function. It is a built-in function within Python, but it is a function. And so all we do here is we call a function, we open parenthesis, close parenthesis, and we put a literal string hello world. All we're gonna do here, and we're gonna run it, and it's going to print hello world, right? The good old getting started. And yeah, so I'm also, if you guys want to follow along on your own time, this video is going to be available, I believe it's being captured and it's going to be available for about 2 weeks. And then I am also recording this session, so I'm going to publish that on YouTube and send you guys the link as well. So it's relatively straightforward as far as production of this is concerned. That's part of the reason why I'm doing it this way. Okay, so at this point, we are in our hello world land. Let's move on to variables. So let me see real quick here. I have my console. So within console, I'm going to and let's do update to 1. All right, and it's going to update to the next thing. So shortly, it's going to actually change up the screen for us and indicate where we're going. So the next thing, so next thing we're going to do is we're going to get the take a look at variables, right? So first thing we want to do is to click on, sorry guys, so yeah, we're going to go to Replit. So we're going to switch over, we're going to run with file variables, which is at the very bottom here. And so let's go to Replit, and instead of hello world, we're going to change it to variables. And as you can see, the current topic changed as well. So that works. And so if we run it right now, the hello world will disappear and it is just going to run nothing, right? Because the variables file is presently empty. So let's go in there, and I have a little bit of comments here just to kind of give us an idea of what we're going to be jumping through within this session. So we're going to start with the fact that Python is a dynamically typed language, but it is a strongly typed dynamically typed language, which means that Python avoids the notion of type coercion. So there's some normal behaviors that you would expect, which we would explore, but there none of that madness, of adding string 0 to value 0 and doing that type of stuff. that you could accomplish in JavaScript. Python is pretty specific with its types, and we're actually going to jump through a few hoops to actually create a type error. So the first thing we're going to do here, we're going to explore declaring an integer. As you know, Python does not require you to put a type in front of a variable when you declare it. So essentially, declaration of a variable with its type occurs at the time of assignment. So if we're going to type in first and we're going to set it equal to 1, right, we next going to just explore the value inside the variable first. And the next thing we're going to print type of variable first to see what comes up. So let's put those 3 in there just to see what's happening. Let's hit run on that. So what we're seeing here is that because our print statement is there, we are printing content of variable first, and it's just 1. And when we are asking for a type, it's of type class int. So that's the individual variables are of built-in classes in here, and so that's what dictates the type of first variable. That being said, we can assign first value, and we'll do it later, to any other value, and at that point it's just going to be pointing to the new literal and no longer be pointing to the original value. So let's go take a look at the float. So we're going to do second, and we're literally going to say 2.2, and we're going to do the same print second, and we're going to do print type second. All right, so nothing, again, particularly exciting. So we see to type 2, because we have assigned it this particular value, it jumped to float. Python doesn't bother with variances of sizes of integers and floats and things like that, and so this optimizes it for basically humans to program in it, so you don't have to jump through the hoops and worry about that stuff. At the same time, there is some of performance and memory allocation penalty for that, obviously, because if we're dealing with one largest size, that's kind of our life there. So we're going to declare a boolean next. So it's going to be third equal. So there is a keyword for boolean value true and for boolean value false. It's an uppercase T true, uppercase F false. And so we're going to assign third to true. We're going to print third in here, and we're going to print type of third as well, just to again get us an exposure to what is that we're dealing with. So here we see value true, and it's printing the value as it is. So we can do false just to see what happens. Switches over to that, not a big deal, right? So let's go back to setting it to true, just to show you kind of a few things afterwards. I'm going to quickly declare a string. We have a whole section on strings and kind of their idiosyncrasies and interesting capabilities. So I'm just going to declare a string literal. Fourth, it's going to be some interesting stuff to print here. I'm putting this, you guys can put anything else. One important thing, by the way, there's no semicolons at the end. You could put one, but it's actually language legal to have semicolons at the end, but that is usually done so that you can do another statement, in line. So semicolon is acceptable in the language, but you don't need them. So I like that. All right, so let's go with, we're gonna print fourth, and we're gonna print type fourth, just to see what we get here. So let's run that. So some interesting stuff to print here. So cool, so we got that, right? So let's try to see, like, hey, when we're talking about dynamic typing, what does that, well, dynamic typing but strict typing. So it does normal things that you would expect. So if we would print first plus second, it's not going to be stingy about it, and it's going to actually produce result 3.2, right? It's going to go like, yeah, it's fine to add integer to float. Interestingly enough, if we go print, that's why I wanted to put true instead of false. If we do print second to third, right, it's still gonna be okay with that, which I was exploring that. Sorry, I double clicked on that. I was exploring that, and that was kind of interesting to me, that I kind of expected it to crap out because there's different types, but it didn't. It actually promoted a Boolean value of true to 1. However, if we do print, first plus fourth, we are going to get this. So we are going to get type error. All right, I got dropped off on this side real quick. Let me see. I wonder if I'll be able to reconnect. All right, so I'm just going to kind of proceed here and see if this side will join me, maybe not. All right, so we're looking at this thing here. I'm gonna turn off my camera so it doesn't go crazy. Cool. So yeah, so we have this thing here. So we do get type error, unsupported aberration type for int and string. So it does not allow you to add disparate types in that sense. And you're always able to look at the types of variables, and we'll go through various exercises with function names and things of that nature, and how that whole thing plays out in Python. So okay, yeah, if you guys want to hang up and to preserve bandwidth, I have no problem with that. And maybe I'll just talk through chat through Learning Channel if you have anything. Let's do that. So I'm gonna hang up as well. All right, so we're gonna Houston in the dark. Let's keep going with that. We've gone through variables, and I think that's sufficiently straightforward as far as that is concerned. So I think we have we have 32 minutes, so we can definitely dig rather deep into collections. So let's go with that one real quick. I believe I have just that. All right. So next one is going to be our collections, and this is where things get quite interesting. So one of the things that's going to be just a little bit different about the file name, we're going to be using this file called Python collections.py. I ended up kind of ruining the whole experience in one of the sessions by just naming it collections.py. It actually overrode some behaviors in the system because of this implementation. So it has to be Python _collections.py. So that's the name of the file. So we're gonna go into Replit like we do with previous ones, and we're gonna do Python collections.py, and let's run it and make sure that it's actually capable of running it. And we're coming back with an empty line. All right, let's go and check it out and actually start playing with it. So we're gonna cover collections and all the wonderful things we can do with them. So you guys might have heard or might have even used pandas and numpy. Those are really super capable, super fast libraries. The ordeal with Python in general is that you have an underlying C code in Python, right, that then turns into a Python language. You also have a Python API where you can write special libraries in C, integrate them with Python API, and so you would have a C library wrapped in Python being able to call directly from Python. So a lot of super powerful, super fast stuff that is done within Python basically treats Python as glue for C code. And up until probably version 3.6, there was a lot of like supplemental libraries to Python that were very performant. As of version 3.6, async.io became the native capability of Python, and it's also super fast in general. So going to that, coming back to kind of here. So we have this, NumPy and pandas and various other libraries that handle collections, that do all kinds of parallel processing and all kinds of crazy stuff like that. However, we're going to be exploring specifically collections that are built into the language. So collections that are native to the language and built into Python are, again, they're C code backed, and they are optimized for performance. And yeah, they're capable of doing a lot of wonderful stuff very quickly. So the first thing we're going to explore is our good old friend tuple. So tuple, or tuple, I call it tuple, either way. Tuple is a what's called non-mutable collection. So when we want a set of things grouped together in an unnamed fashion, which there are occasions when you want to do that, and we'll look at some of them, you create a tuple, and there's a lot of tuples being exchanged and emitted and managed within Python. So we're going to explore, actually, let's start with declaring one. So if we want to declare an empty tuple, we're going to do, I'm going to again go with first. So we're going to declare it an empty tuple. Unfortunately, there is no shorthand for empty tuple. So we're going to explore everything through print, and again, we do type first, and we run this. So all we did right now is created an empty tuple, which is not super valuable, but the tuple itself is normally normally visualized in the form of parentheses. However, if you just do first equal open close parenthesis, it's just going to be equal to nothing, because it's not going to evaluate it to tuple. If we want to add a single element to tuple, so I'm just going to redeclare first again, or I'm just going to even be more lazy than that. No, let's do this. Sorry, let's go here. Let's go past this, and we're going to go. First is going to be again equal, but it's going to have tuple with a single element. So we're going to go. So I'm going to put a string as a single element. So what you do is you open parenthesis, you put a value in, and you do comma, and then close parentheses. So if you do, I'm just going to copy line 9 and 10 over. Copy it over. And print it again. And so this time around, see, it has single element in that. Let's make it simpler. Instead of single element, I'm gonna just, I don't know, put 1 to 3.4 just to make it a bit more pleasing. So it's still, if you have a single element go in, you put open parenthesis, put a value in comma, close parenthesis, and that declares a tuple. So we're going to declare a more elaborate tuple here. So again, tuple is a collection of variables of various types, right? So it doesn't have to be a single type, as is true pretty much with every collection that we have. So it doesn't have to be a single type. So when we do this, we are going to go and let's try accessing our elements. So we're gonna declare a second, and we're going to do 1, 2, 3, comma test, comma false. So we have just a collection of things. So if we want to access an individual element, we are going to access it as if we're accessing an array, a list rather, sorry. So we can access it by element number from beginning, and it's 0 base. So if we print second 1, and run it, we're gonna end up with a string test. You know, if we print I'm doing wrong, Control-C, Control-V, sorry. If we do, you know, print the second element, we're going to print false. And if we try to print third one, I'm just going to do it real quick. It's going to error out on us, right? Tuple index out of range. So we have that capability here. The interesting thing is, as I mentioned before, one of the most valuable parts about tuple is that it is not mutable, so, which means that we cannot change any elements in it. So if we go second, you know, sub 2 equal to true, right, it's actually going to give us an error. So tuple object does not support item assignment. So it is valuable when you want to transfer state, you know, you want to pass a set of things related to each other and you want to transfer state, you know, into a different function. You want to make sure that your values do not get mutated and that function does its own thing to return results. We can ensure it by assigning values into a tuple. There's another rather powerful capability that tuple has, and that is ability to unroll values. So we have this, you know, the value called second has three elements in it. So one thing we can do is we can actually unroll those elements into individual variables. So if we do a comma b comma c equals second, when we do print a, print b, and print c, we end up with this. I need to probably stop blowing it up. Probably should comment this out in order to actually not have it go wrong. So what we see here, let me do something else just so we can see what's going on. I'm just gonna put a bunch of lines here just so we see where the alignment is. So what we did here, we literally took second, right, which contained I'm gonna print second as well, print second, right? So that's the way it is in present state, right, as a second, and then we can unroll it in multiple values. The cool part there is that it means that if we are returning a tuple value out of a function, we have means of returning multiple values out of a function if we wanted to. And you know, in some cases it makes sense, and you know, we need to. The only concern there is that if you return a tuple, you can either take it into a single value, or you have to have exact number of values you're unrolling it into. So that's going to be an important thing there. But it actually, tuple will explore you will explore we'll explore a variety of returning values from the functions, and we will see how that plays out. Yeah, let me know, guys, if the video is freezing for you. It's kind of a you know, mixed rate at which it goes through for me, so I'm hoping that it's sufficient that you can hear me still. Let's see. All right, so we have, where are we? We're at 2:39, so we have enough time, I think, to mess with lists and see what they could do for us. And then we'll probably explore sets and dictionaries next time around after a quick review of what in the world happens. So with lists, list is a collection that, you know lists from Java, so you would have lists, arrays, and things of that nature. The deal is that lists, like other collections in Python, hold kind of interesting special powers that are intrinsic to the language. So they are not even, so list types are not even libraries that are, collection libraries in Python, or whatever. They are literally built into the language. So that's where the power and the speed for them comes in. As all these collections that I'm actually showing here, they're all native to the language. As you've seen, we did not import any libraries here to be able to use this. Okay, so let's look at lists. So we're gonna do, let's do test. Just so I'm gonna need to be imaginative with the names. So we're gonna have test. So we're gonna declare an empty list, the usual print test, and we're gonna print type test. So just you see that I actually mean what I say. I'm gonna copy the okay, so I'm gonna copy this line in here just so that we can see the delineation. All right, so we're exploring the next thing. So we have an empty list that we declared here, and we are, we see class comes back as list. So there is essentially a, a symbol for list, which is square brackets. So if you do test equals square brackets, that is going to automatically create list. So we have that. We have this little while capability creating. So if you have a list and you need to create list full of if you have list full of say zeros, so you need to create a list like of 20 elements of zeros. So we're gonna go test equal, and we're gonna just go element 0 20 times. So if we do print test, it's gonna come back like this. So whenever we need to create lists that are okay, good. Yeah, you guys are finally seeing my comment about freezing. Cool. So yeah, so the cool part with lists is that you have an opportunity to really do this type of you have an opportunity to do this type of stuff where you can literally take an element and just tell it, hey, I want it 20 times. So the interesting part is we can do the same thing with strings. So like I had this print and added a bunch of dashes. Going forward, I'll just use multiple to actually create those lines just for visualization purposes. So we have our print test going on here. So as you could probably guess, let's make test 2. I don't know, and let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So we just make our list that we can actually mess with. So let's access it, right? So it is as you expected. Test2 sub 4 is going to return us 4 because we started at 1. No, it returns us 5 because I can't count. It is 5. Yes. So it's the 5th element in the list. So the access is as you would expect it to be. Let me see. Mutating list. Yeah. So we can actually just go test2 sub 3. We can set it to 1 to 3, and if we print test 2 at this point, let's print it before and after. So if we print it before and after, we're gonna get our, obviously, our 4, element 4 now is 123. So elements in the list are fully mutable. So in fact, you can, if you pass a list into a function and modify a value in that list, you're actually going to modify the original copy. So this is just kind of as a heads up. But yeah, so any element in the list is absolutely mutable. The other thing is that list, just like tuple and just like really any other collection, it's not type specific, right? So you can absolutely have we're going to have test3 is going to equal to 1 to 3 comma false comma test comma none. So that's one thing we actually didn't discuss, is there is, oh, it doesn't do anything because there's nothing to print. So print test 3. So one important thing I should have probably brought up in variables, there is a notion of a value none, which is equivalent of null in Java. And so that is the way that Python handles non-values. Every single non is non-type specific. So print, let me see if I can do that. Sorry, because I brought it up, I'll just do it here. Let's see what it does. Yeah, so none is of non-type, right? So it's kind of a special beast in its own right. Sorry, because I remember that I just bring it up here. So any value, any variable could be assigned to none and could be checked for that as well. So we will explore, there's a section on Boolean logic, right, which is kind of a, it seems like a given thing for any language, and it's not particularly magical, but within that section, I'm actually going to explore the notion of truthiness and which value is considered true, which value is considered false, and all those things, right? So there's a lot of kind of interesting, quirky things that all the languages have, but it's worth exploring that kind of in depth. So let me see here. Just for lulz to see what none does. Yeah, I'm just putting a comment in here because it's kind of random drop in there. Now let's take a look at this crazy thing here that is called splicing. So that's where the first kind of powerful exercise comes in with lists. We have an ability to cut lists in any and every way possible. So I'm going to do this one quick thing here of list comprehension, sort of, don't mind me. We will actually go in, once we look at the for loops and things like that, we'll go into what the heck this means. I just need to create it so I could create a quick example for us to splice and for you to see what's happening. So we're going to have a sample list, and we are going to go I for I in range 20, and then print sample. Right, so don't mind what's happening here. Essentially what I'm doing is I'm creating a list of 20 elements. Okay, and I created so that it is sequential. Right, so next thing that we're gonna look at, we are going to, let's do this thing here before splice. I'm going to print, and remember that multiplication thing, it works on strings as well. So I'm gonna do equal sign times, let's go 50, that's probably too much. No, it looks good. So that took a string of equal sign and did it 50 times over, and that's what I'm printing out. So that gives me a nice divider. Cool, moving on. So we have our good old buddy sample here. We created it, we ran a for loop inside of it, list comprehension, we'll touch on it. We used a generator called range. We generated 20 elements, and we put those in a list sequentially. That's what we have here. We'll play with it later. For right now, we have this nice sample that we can play with. So first, interview question. Invert the list. No, you know what? Let's not start with that. Let's start with accessing every even element. So we're gonna do print, and we're gonna do sample, and we are going to grab. Let me see if I remember. Let's see. I'm gonna have to. No, that just gets me up to that. No, so sorry. Let's do this. Let's actually splice the list first and get up to a certain point. So I want the first 10 elements. So that's what we're gonna do. So we're gonna run this, and we're gonna print, and we get the first 10 elements. So what's happening here is we're gonna say sample, sample square bracket colon 10. So what we do here is we take everything from the left of the list up to and including element 10, right? And that's what this line here shows us. Sorry, no, I'm gonna zoom out because this is crazy. Please come back. Yes, so that's what that line over there shows us, is that we grabbed the first 10 elements. Now we're gonna go and say, hey, we actually want to grab the element starting at 5th element on, right? So we're gonna do that. We're gonna go 5 on, and so now we go from 5th element, right, to the 20th element here. So we have an opportunity to actually just cut off the tail of the list and then move forward. So that's all great. We can obviously combine them, right? So we can do print sample from 5th element to 12th element, something like that, right? So we're going to get just a subset of these things. So that's all kind of cool and very useful. Well, there's a third piece to this colon ordeal, and so you can do sample, and the thing that we can do if we do 2 colons, so the first element to the left of the colon is where we start from. Element after the colon is where we go up to. The third element is a step. So if you go sample 2, you're gonna get all the even numbers out of the list, right? So now we go to that interview question of please inverse list. So you go, it's literally this. So you get your list inverted in a single call here. And so as you can imagine, being able to splice kind of tricky alignments of data within Python is actually a meaningful exercise, and it works works rather well. So I'm just gonna zoom into this piece over here and let you guys take in these few things that we did. Let me look at the time here. We have 2:54. So we have 6 minutes. I'm gonna wrap it up because I would like to kind of experiment and jump around with this thing. So I think I'll leave it for next time, and we kind of start doing some beefy stuff and messing with lists a little bit more. And I'm going to switch back over to the other channel if that works. And let's talk later.